Hello everyone. In this video, I'm going to continue to use the product to sum and sum to product formula to do some examples. In this example, it's quite a long time for us not to do the mathematical induction. So I'm going to do an example about mathematical induction and the trigo formula. Part A. To do this, we need to start with the case when n equals 1. And when k equals 1, you must be very careful that to check the general term here, whether it's the same as the very first term. Okay, don't ever try to copy the first term. You may need to say that the left-hand side is sine of 2 to the power of 1 minus 1 theta, sine of 3 times 2 to the power of 1 minus 1 theta. Okay, and if you get sine theta, sine 3 theta, then that's guarantee is the very first term when n equals 1. And what's on the right? The right is the difference of two cosines, so you need to change it to difference of two cosine. So cosine of, do you still remember we usually place the larger angle in front, so I interpret it as sine 3 theta times sine theta. So we have cosine of 3 theta plus theta minus cosine of 3 theta minus theta. Okay, don't ever skip this step. Okay, write literally 3 theta plus theta and 3 theta minus theta. And you will get negative 1 over 2 of cosine 4 theta minus cosine 2 theta. And you make this negative sign inside the bracket and reverse the term, and also rewrite this 4 as this form. So we have cosine of 2 theta minus cosine of 2 to the power of 1 plus 1 theta. And that is the right hand side. And therefore, the statement is true for n equals 1. Second part, you need to assume the case is true for n equals k. So we assume the statement is true for some positive integer k. And that is this one is equal to half of cosine 2 theta minus cosine of 2 to the power of k plus 1 theta. And then we work for the case when n equals k plus 1. So for n equals to k plus 1, the left hand side is actually something like this. And you still remember, I suggest you to write literally the assumption you use, okay, the terms that you use for assumption, and then an additional term when n equals to k plus 1. So we have sine of 2 to the power of k plus 1 minus 1 theta and sine of 3 times 2 to the power of k plus 1 minus 1 theta. And then for the yellow part, we use the assumption that is equal to half of cosine 2 theta minus cosine of 2 times 2 to the power of k plus 1 theta. And here is the product of two sine of 2 to the power of k theta and sine of 3 times 2 to the power of k theta. And since you know what's on the right should be the difference of cosine, so you try to rewrite it as the difference of cosine. And so we include the 1 over 2 in a larger bracket and copy these things. And for two sines, the difference of cosine, we start with a negative sign in front. Okay, make sure you don't forget it. Difference of cosine, we have the addition of angle. We start from a larger one. Okay, make sure you always start from a larger one. So we have 3 times 2 to the power of k theta plus 2 to the power of k theta and minus cosine of 3 times 2 to the power of k theta minus 2 to the power of k theta. And so we simplify the things that we have just done here. We have minus of cosine of 4 times 2 to the power of k theta and plus cosine of 2 times 2 to the power of k theta. And you know that 2 times 2 to the power of k is just 2 to the power of k plus 1, so these two can be cancelled out. And also, we can write this 4 as 2 squared, and the 2 can be absorbed here and make it as 2 to the power of k plus 2. But in order to complete a mathematical induction, we need to write it as a k plus 1 and then plus 1. So in the end, we have cosine of 2 theta minus cosine of 2 to the power of k plus 1 plus 1 theta, and which is the same as the right hand side. Okay, so the statement is true for n equals k plus 1 if it's true for n equals k. Okay, and of course the statement is true for n equals 1, so by the principle of mathematical induction, the statement is true for all positive integers n. Okay, and that's it. Okay, so this is part A, and there's a part B there for hence question, hence evaluate this kind of thing. Okay, for this kind of short expression, you can actually input your calculator to check your answers. And for the word hence, you need to make use of the above results. So we can just compare term by term. That you may think of theta is 12 degrees. And also, you need to match with the last term here. Okay, there's an n here, so you need to know what's n. And so, what you need to do is to do it in this way. Let theta equals 12 degrees and 2 to the power of n minus 1 theta be 96 degrees, And also, it's better for you to also check the remaining term. That is the latter one. Okay, 3 times that thing. Okay, whether you get this n being 96 and if this result is 288 degrees or not. Okay, so we do all the things here. And 3 times 2 to the power of n minus 1, theta is 288. Okay, so from here we get n equals 4. And here, can we get 4 here? 288 divided by 36 is 8 again. Okay, so we guarantee that n equals 4. And so the required sum is equal to half of the cosine of 2 times 12 degrees minus cosine of 2 to the power of 4 plus 1 times 12 degrees. And what is it? 2 to the power of 5 times 12 degrees, 2 to the power of 5, and then times 12 degrees is 384. It exceeds one whole circle, so we can reduce it by minus this angle by 360 degrees. Okay, and it's also 24, so you know that the result is 0. And actually, you can use your calculator to find the result. Okay, that is 0. It's not very necessary for you to notice that 384 degrees for cosine is the same as cosine of 24 degrees. Okay, but then if you want to be very clear about that, you can say add 2 steps, like cosine 24 degrees minus cosine of 384 and equal to 1 over 2 cosine 24 degrees minus cosine 24 degrees. Okay, you may add these 2 terms, but then it's not quite necessary. Okay, because for the word hence, you need to be very clear that how to make use of the above results, the value of theta and the value of n, and you plug it in, and then to have this kind of expression. Okay, these 2 steps are more important. Okay, theta and n, the first one. Second, you rewrite the required sum as what shown on the right hand side of part A. Okay, so this is example 6. Okay, that's all for this video, and there are some more videos coming up for product to sum and sum to product formula. Stay tuned, and thanks for watching.